Hello humans, welcome again to the Touchdesigner training course. Today is the fourth session of our month of content, and today we are going to be focused in one of our main goals. That goal is to share between our team members the same language and also to understand what is the logic behind Touchdesigner, to be able to explore one project that we can find here in the derivative.ca, that is our first resource of content and information related with our software and our platform, or any other project that you can be working on that maybe you can get from one colleague or you can find inside a forum in Facebook or anywhere in the internet. So as I just said, this website is our first and most important resource of information related with Touchdesigner. Here is the documentation, here is the community, here it's also all the content related with learning. So this is one of the things that we are going to explore today. So after we go to the homepage, derivative.ca, we are going to click in Learn, and this is going to send that here, or we can also find here in the sub menu User Guide. Here in the User Guide we will find a complete timeline of steps. For a different information, we'll always begin with getting started. And here we'll find different information about installing, licensing, and more detailed things about stuff that we already did. But now what we are going to check is learning Touchdesigner. And for that, we are going to find here in the second link, first things to know about Touchdesigner. After that, we'll find here a few tips that we already cover and a few others that are more related with specific uses. But what we are going to explore today is this specific part that are the Sweet 16 operators of the four most important families: the chops, the tops, the subs, and the dots. So here we are going to explore the Sweet 16 of every family using our snippets inside Touchdesigner. So we are going to begin with the Sweet 16 of the shops. Here we will find more than the 16 operators. There is information related specifically with the shop family, and I invite all of you that we can explore this information because we can understand the things in a really deep way. But for now, we are going to begin with this. So the first thing that we are going to choose is the constant. Our Touchdesigner snippets. We are going to create a new project. And again, we remember, if we need to go to the snippets, we go to the main menu, help, operator snippets, and this is going to open another window independent to the main project. So now we are going to go to the shops and we are going to select constant. Again, here in the snippets we will find always different examples of every operator and also a description. So for what we are going to use constant. The constant, as it is say here in the descriptions, creates new channels. This is the way that we can create information based in channels, thinking in a numeric way. So in this way we are not going to bring information out with any input. We can create it with the specific name that we want, and it's really simple. So I'm going to create a constant, and always by default it's coming with just one channel. That channel is called chan1, and it's always in 0, but we have here this slider that it's really important that we understand that we are not limited by the range that it's available here in this slider. This is just a way that we can interact in a really simple way with our parameter, but we can put numbers higher than 1, maybe this one, and it's going to get the number. Anyway, if this is not that range long or whatever, we are not limited by the sliders. And we can change also the name. So we can use here, for example, length. And this is the way that we are going to create different channels inside a channel operator. As you can see, we can make so many channels. We can use notations to make different channels with just one script and give to those channels a specific name, for example, like this. We can do it using scripts, and we can program different kinds of solutions, creating new channels through the constants. The next operator is LFO, low frequency oscillator. In this case, we are also using a generator. When I say that we are using an operator that is a generator, is that we can create information with this operator in the same way that we were doing with the constant. When we are using a LFO, we are using an operator to create a wave with a certain behavior depending on their parameters. So as we can see here, all of those 4 are the LFOs, and all of them are making a different kind of wave, and depends of what we have here in our parameter defined. So wave types, in this case the sine wave is this one that it's round in the top and on the bottom of the wave. We also have a sine wave but with a short frequency, so it's more slow and we can see more the details. We have triangles wave, and in this wave we have no acceleration. It's always a straight movement, and in that way we create this kind of behavior. And we also have pulses. In this kind of way, the change between 0 and 1 it's almost immediately. I mean, it's not like this one that has time to get from 1 to 0. In this case, it's completely 1 or 0. And there's another one that it's called a square, that stays on and off for a while, but anyway the change is without deceleration, like in the pulse. Okay, so now we have the third is noise, create semi-random patterns. To choose here noise, and actually when we are talking about noises, it's always because it's random information. The noises can be expressed just like a trail with a certain information in every frame, but in a static way, or we can always make this random information time slice. When I say that it's time slice, it's because it's attached to the time slice that I'm using in my project. So if I turn this on, I will have the value of my actual frame, and it's not expressed in a long wave like if I do it without the time slice. Here we have more examples. For example, the animating the seed creates motion of the noises. Here they are using a change in one of the parameters to make the change inside the noise. But in this case, it's not time slice. It's time slice, or is changing in the time because one of the parameters is changing based in another value. The next is select. Grab a channel from any other shop. That one was one that we already used in our project. We're going to look here, and so when we are using select, we can do so many things when we are selecting different kind of channels. In this case, the first example is renaming the channels. Here the select is using all the channels available. They are using here the asterisk, and they are renaming all of them. And in this case, we have 4 channels, for example. Those 4 channels are always in an order. In this case, Chan 2 is the first, Chan 3 is the second, B3 is the third, and B4 is the fourth. And when I use this box here and I put any kind of alphanumeric content and I separate it with a space, that means that I'm giving a name in a specific position. So this one is going to be the name of the first Chan 2 is going to be TX. Chan 3 is going to be TY. B3 is going to be RX, and B4 is going to be RY. So this is one of the ways that you can also use the select. Anyway, there is another operator that do the same work that is called rename. But anyway, it's one of the utilities of this operator. We can use it to select operators with a specific behavior. For example, here they are using Chan and they add at the end the asterisk. That means that they want any channel that has Chan inside their name. Here we have Chan 2 and Chan 3, and they're also using the same technique to rename it. In that way, they put D and any number that it's available, so the name is going to change to D2 and D3. And there are so many other examples. The next is merge. We also already use it. Merge here. Merging multiple channels into one chop. We used to aggregate different information that is separated in different operators in just one operator, and this is going to be organized as different channels inside one operator. In this case, the use of this function is that we can see here that we have different operators with channels with the same name. So when we use here duplicate names and make unique, the operator is going to organize it and give a different name to each one of those operators and channels. The next is math. Add, multiply, or scale channels. We already also use it in our first exercise. Here we're gonna find different examples also, so we can use it to combine chops. For example, here we have one chop with a channel that it's a value of 2 and another that is a value of 2, and when we use it here, combine chop with a function of add, the value here is going to be adding those two numbers here. So I can change here and put 6, and 6 plus 2 is going to be 8. I can change here also and I can put 6, and 6 plus 6 is going to be 12. And in the same way we can do it by adding, what is the difference here, add chops, roots. For example, here they are using negation, so the value is going to be negative. And all of this is going to be useful when we are trying to do any kind of logic programming. We also saw how can we change ranges. And if we explore, we are going to find different examples when we will use those kind of operators. The next is lag, smooth and delay a channel. Lag, here we have examples that we need to interact with. For example, here say click me. If I click, I see how this is working. It's if just using nulls. But if I use a lag value, I can see the difference between the wave that was created here and that one that is created here. So when we are talking about lag, is going to make like a smooth behavior of that wave. Look how different. This is just drop to 0, and this is going to take like a time to go from 1 to 0 in a smooth way. This is, for example, useful if we want to animate behavior of a number or something like this. And there are so many other examples to explore. The next is speed. Use speed to calculate distances. For example, speed also can be used to create constant numbers that are running based on the behavior also of our time slice. For example, here we have an example that is of how to count seconds using a speed chop. So we can use go, and I stop, and that shows that I was on for 7.7 seconds. And I can restart, and I can use this just to calculate the time of something that is happening in any of our programs. And there are so many other examples to explore. The next is lookup. Use one channel to get values from another chop. Lookup. For example, this is a little bit more advanced operator, but it's really useful here. The example shows us that we are going to interact with a slider that is going from 1 to 0, and that value from 1 to 0 is going to be related with the length of this wave here. So you can see here how the bar is growing, and while it's growing, I'm gonna make it bigger. All of this area is from 0 to 1, and it's exactly the way that is going to be related with the wave. So when we are in 0, it's because we are going to begin here, and every time that this bar is growing, is going to be using or getting the value from that area here in this wave. So from 0 to 1 is the same from 0 to 1 here. So when we see the graphic here in the trail, we'll see how this works. If we do it like fast, we are going to see the wave in the same wave that it's visualized here. But if we do it slow, this is going to take the time to create like a random content. And we can see many other uses here. It's kind of advanced operator, but it's really useful. The next is trail. What's a time story of a shop channel? In this case, the trail is really useful to visualize the behavior of a number. We always use it, for example, if we have a noise that it's timeless, or there is something that is getting inside of our system, like a microphone, we can visualize this information using a trail. So this is going to graphic the behavior of this number based on the length of my graphic. In this case, I'm just using a 4 seconds length graphic. This is visualizing the behavior of my wave of the last 4 seconds. The next is the sub 2, record a time story of channels. So when we are talking about this kind of operators that ends with a 2, is because we are trying to translate the information from one nature to another, from one family to another family. In this case, we are inside the shop family and we are trying to bring information from the surface operators to the shop operators. So for example, here we see an example where the information of this box that is made of 6 different rectangles with vectors in the corners can be also visualized or interpreted as waves. And here what we have is the representation of all of those vectors in the 3 different axes, tx, ty, and tc. And also here we are using a noise to edit and alterate the position and the behavior of this wave. But anyway, we are still preserving the structure. The only thing that is changing now is the value of those vectors, but anyway the information is still related with the 3D context here in the sub. So after that we can recreate again this information, and this is how looks this box here when it's blend with a noise. So here we are talking about translating information, editing that information in that nature. So here is one nature of information that is 3D visualized, but that information can be translated to shops. In shops we can edit it with a noise, and after that we can also go back to the sub representation of that information and visualize it as a 3D object. It's really powerful, and this is one of the most important things to understand with Touchdesigner, and is that we can translate information from one nation to another. The next is limit, restrict channels to a range or send certain step values. Limit. When we are talking about limit, it's that we know exactly what are the values that we are waiting in a certain process, and we can make sure that anything is going further or below from something, and he will find different kind of examples. Let's see what is here. The use that they are putting here is that they don't want any number below minus 0.5 and any number higher than 0.5. So even if the LFO is going higher and lower than 0.5 and minus 0.5, this is just going to get the information in that specific limit. We also can find loops, zigzags, and as you can see, we always can interpret and visualize everything as graphics if we are talking about numbers, and this is going to let us understand better the behavior of our information. The next is audio devising. We also already use it. This is one of the ways that we get information out of our system. In this case, you will see here that I can select my microphone, or I can select another like this one. And you will see how my voice is going to be graphical. The next is the OSC in, and when we are talking about OSC OSC, that means open sound control. That was that is a protocol especially created for the music industry, and we can get that information through Wi-Fi. We also can create OSC out to send information to another system through this protocol, and it's really powerful. It has a specific range of values and a specific way to name the channels, but if you already use a program that it's available to make connections through OSC, it's a really good way to integrate with Touchdesigner. The next is panel, get the state, UV, etc values from any panel gadget. So when we are talking about panels, let's see, we have panels. It's because we are inside a container. So let's see what is here. For example, this element, it's also a container we can get inside, and what my panel operator is getting from this container is the information when I get inside the bottom. So it will show the axis, vertical and horizontal, if I'm inside or not in rollover, and if I click the state, it's on or off. And it's the same, but with every panel I will get different information. For example, here the slider also understand if I'm clicking Control or Alt, but just it works if I am inside the container. I mean, my mouse need to be on top of the slider, and I click Control, and this is going to be activated. If I go out, this is not going to be activated anymore. Shift Alt select or the position of the element. So as you can see, we'll find different examples that are pre-programmed and that we can use in our networks. The next is going to be in last timer. Run timers, loops, delays, and trigger events. So this is one of the operators with more examples. And let's see what is a basic timer. Here we have a start and init. If I do a start, I will have information that I can also visualize, and it's going to be working based on conditions here in my parameters. So I said how long I want my timer, when it's going to play, if I want it slow or fast. Let's see what other examples we have here. Timer start, for examples. Here is showing fractions of seconds, timed seconds, if the condition was done, delay in cycles. This can be a little bit confusing now, but when we use it in a solution, we will see the real power of this operator. So with this, we are finishing with the first Sweet 16, that is chops. Now again, I invite you to explore the system by yourself, to go to the snippets, to go to the forums. The forums we will also find here in the Learn. It's really useful to try to find a solution that maybe you had in mind. For example, I can look here for example, a countdown. If somebody already make a countdown, and I can see here that somebody made a 3D particles countdown, and the people make a question, they have already any example. There's people that already make it, and they also create a solution and they share it. I'm gonna download one of them. I'm gonna open it, and let's see what we have here. This is a project that I just found in the forum. I haven't seen before, but I can understand how it works because I can make inverse engineer. So in this case, I'm getting here a number that it's created with particles. I can see here the system of 3D objects that create those particles. Those particles are represented with these chops here, and were first animated here in real time based on the behavior of this number here. So first we are creating a text with a number. After that, that number is going backward. After that, that number, it's interpreted as pixels, and those pixels were made like a more random and pixelate style. After that, that was transformed in a 3D element, and in that way this 3D element will create vectors to make particles. So this is the way that we will need to understand our system. We don't understand how to solve a problem. We go to the forum, we ask to the people, or we ask to the forum if there is something that is related with my idea, I download the things and I saw how it works. Because we don't need to begin from scratch always. We will always find solutions that were already made. So this is my invitation. We are going to be doing those Sweet 16 operators in the next sessions and also in the video calls. Thank you very much and see you in the video call.